Sometimes we're asked to find a polynomial function given a graph rather than just being given a list of zeros. So there's a lot of overlap between those two circumstances. The big difference, though, is that there's a coefficient a in front here that we're going to need to solve for when we're given a picture to work from instead of just a list of zeros. But from the graph, we are going to be able to obtain the zeros. So we can see a zero here, here, and here. And so those are going to be used like we have previously, where we're going to take x minus whatever that value is to write those zeros as factors. But then I need to pull one more point somewhere from the graph to help me figure out what that value a is, the coefficient. When we're just given a list of zeros, we just assume that coefficient is 1. But when we have a graph, we have to figure out what that coefficient is. So to get started, I am going to ignore that coefficient. I'm going to leave it as a, and then I'm going to fill in the zeros first. So for this 0 right here, since it's -4, the factor associated with that is going to be x minus -4, or x plus 4. Then we've got this 0 here, so that's going to be x minus 1. And then our last 0 is that 3, 0, x minus 3. So that gets us started. But I still need to I still have to figure out what a is. So the way we're going to do that is by using some other point that is given to us on the graph that we can find. And that's this one right here. Now that's not a 0, that's a y-intercept. So it doesn't get the same treatment as the factors. Instead, the -6 is the y-coordinate and 0 is the x-coordinate. So I'm going to plug in -6 in place of f of x, because of course remember f of x is basically just y. And then in place of x everywhere else in my equation, I'm going to plug in 0. But a is still going to be there. So I have a times 0 plus 4, and then 0 minus 1, and then 0 minus 3. So I know my graph goes through this point 0, -6, so I'm just plugging it in for x and y, which will then allow me to solve for this a right here. So we've got -6 equals, I've got a times 4, 0 plus 4 is 4, 0 minus 1 is -1, 0 minus 3 is -3. So then if I multiply out the numbers over here on the right, 4 times -1 times -3, I'm going to get positive 12 out of all that. So I have 12 times a. And so then to solve for a, I'm just going to divide both sides by 12. And so then we get a equals -1/2. So be careful, that's not -2. We've got -1/2 after we reduce that fraction. And so now, in factored form, we can write our function as f of x or y equals, and now we've got -1/2 times x plus 4 times x minus 1 times x minus 3. So we've got our function written out in factored form. We've got all the factors instead of multiplying them all out, but now we figure out what that coefficient a is. And we can also kind of confirm by looking at the graph that this answer is probably correct, because we can see that we're going up on the left and down on the right, which would correspond to a negative leading coefficient, which is exactly what we have here. So in the second example, we'll approach it much the same way. We'll start off with f of x equals a, and then we're going to list off all of our factors associated with the zeros. So the first of our zeros is here, so x minus -3 becomes x plus 3. We've got a 0 here at 1, so x minus 1, and then the 0 that's here gives us x minus 2 as a factor. So we've got the factors associated with the zeros, so now we need to solve for a. And so that's where we have to have some other point somewhere on the graph to plug in for x and for the equivalent of y. And so that's this point right here. So in place of y, in place of f of x, I'm going to put 3, the y-coordinate, equals, and then a times, and in place of x, I'm going to plug in 0 everywhere. So we've got 0 plus 3, 0 minus 1, and 0 minus 2. Now in both of the examples here, the point has been the y-intercept. But really that point could be located anywhere. We just have to plug in the y-coordinate for the y and the x-coordinate for the x. But if we continue, we've got 3 equals a times 0 plus 3 is 3, 0 minus 1 is -1, 0 minus 2 is negative 2. So we've got 3 equals, and then if we multiply everything out over here on this side, 3 times negative 1 times negative 2, it's going to give us a positive 6. So we get 6a. And so then I can go ahead and divide both sides by 6. And once again, we get a equals 1/2. Last time it was negative, this time it's positive, and that corresponds to what we see on the graph. We're going up on the right this time and down on the left, so that would track with a positive leading coefficient. But this time, instead of just plugging in for a and leaving our answer in factored form, this time we're going to multiply all of this out and get our answer in standard form. So that way it'll be in descending exponent order, everything will be multiplied out, more like a polynomial function like we're typically given. So that means I'm going to have to do some rounds of FOIL. So I'm going to leave the 1/2 here first, and then I'm going to multiply these two right here. So if I do my FOIL, I get x times x is x squared, then my outer gives me negative x, my inner gives me 3x, so combined negative x plus 3x, I'm going to end up with a plus 2x. And then my last is 3 times negative 1, so I get negative 3. So I have FOILed those first two pieces, but now I'm going to have to FOIL times this third piece. So I still have this 1/2 hanging out in front. I'll deal with that at the very end. And so now I've got my FOIL technique that's going to be used to make sure everything from the first set of parentheses multiplies everything in the second. So we're going to have x squared times x gives us x cubed, and then x squared times negative 2 is negative 2x squared. Now I need to repeat the same process with the 2x. So 2x times x is plus 2x squared, and then 2x times negative 2 gives me negative 4x. And then finally the negative 3 needs to be distributed to both pieces. So negative 3 times x is negative 3x. Negative 3 times negative 2 gives us positive 6. So close those parentheses there. So now I do have some like terms that I need to gather. So I'm going to move up here a little bit. So I'm still going to have f of x equals. So I've got 1/2 times, I've got the x cubed, then I've got a negative 2x squared and a positive 2x squared. So those two cancel each other out, so that's gone. Then I have this negative 4x and this negative 3x. Those combine to make negative 7x. And then lastly, I've got this plus 6. And then to finish things out, I just need to distribute this 1/2 to everything. So I get f of x equals 1/2 times x cubed, and then 1/2 times negative 7 is just going to be negative 7/2. No need to put it as a mixed number or a decimal or anything, just write it as negative 7/2 x, and then 1/2 times 6 is plus 3. So if we're asked to write our function in standard form, then we need to go through this multiplication process. On the previous example, where we left it in factored form, we're sometimes asked to just find what a is, and then that's good enough. Just depends on the circumstances of the problem.